Hi Math 2 students. This is video 3 in Wednesday's videos having to do with Unit 6, Lesson 4, Modeling with Exponentials. And let's get a couple of definitions out of the way about compound interest. Sometimes when you go to the bank, you deposit money and the bank pays you interest for that money. And if you leave it there long enough, they'll pay you your interest and they'll just reinvest it in your account. And then your account is worth more and you begin earning interest not only on the amount of money that you put in, but on some of the interest that the bank has paid you. And this is what's called compound interest. And sometimes you have an account that will compound once a year. Sometimes you have an account that will compound more frequently than that. So we need to take a look at what mathematical models will give us the answers to questions about compound interest. So in your notes, we need to define compound interest as interest that occurs when the bank pays you interest on the principal and also on the interest that the account has already earned. Basically what you're doing is you're earning interest on your interest. And the interest can be charged at different intervals of time. Compounding annually would be once per year. Compounding semi-annually would be twice per year. Compounding quarterly means you're paid 4 times per year. And if you compound monthly, you're paid 12 times a year, and you can even be compounding daily at 365 times per year. So let's see what the formula looks like. It's the same one we've been using. We just have to modify it a little bit so that we take into account the compounding periods. Y is still the amount of money that you have after a certain period of time. A is the principal amount, the original amount you borrowed. That hasn't changed at all. And then in the parentheses, you'll see 1 plus our rate, and it's divided by the number of times that we're compounding. So let's examine that and find out why that is. If you were compounding let's say twice per year, and your interest rate was 6%, the bank would give you 3% interest after 6 months, and then it would give you the other 3% after the final 6 months. So we would need to take our interest rate and divide it by 2. So our 6% would be 3 at 6 months, and then another 3 at the last 6 months, which would be a total of 6. So that's why we divide the interest rate. If we didn't divide the interest rate by the number of compounding periods, your bank would be paying you double your interest. And then, of course, we need to calculate more frequently. So we multiply the time times the number of compounding periods. So let's see how this plays out in a problem. And if I moved a little bit too fast for you to get the notes copied down, just pause the video and take a moment to make sure you've gotten the notes, and then we'll move on. Here's a fabulous example for us to work together. For your birthday, your uncle has purchased a lottery ticket for you, and you learn that your ticket had the winning numbers. The prize is $250,000, but the lottery commission is only going to pay you 52% of the prize if you choose a one-time payment. So that means if we get the money now, we only get 52% of it. So we have to figure out what that amount is. $250,000 times 52% is only $130,000. So the lottery commission isn't going to give you your full $250,000 if you choose that lump sum payment. So you're going to choose the lump sum payment, and you're going to take your check to State Employees Credit Union, where you deposit it in a certificate of deposit for 5 years at a compound interest rate of 3% per year. So we are going to figure out how much you would have at the end of 5 years. So notice my initial amount is $130,000. And then I have 1 plus my interest rate divided by the number of times I'm compounding per year. Notice with annually, I'm only compounding once per year, so there's a 1 there. And then that 1 also appears up here in the exponent because I'm compounding 1 time per year. And if I put this into my calculator, this is the answer I get. I want to show you the keystrokes that I use to do that. Order of operations is really pretty important here. So my interest rate is 0.3, and that's divided by 1. And then I'm going to add 1 because it's 1 plus my interest rate. And then I'm going to raise that to the 1 times 5 power because I've invested for 5 years. And if I hit enter, I get an intermediate value of 1.15 and so forth. And I'm going to multiply that times my initial amount of $130,000. And that's how I got $150,705.63. So that's the amount if I were offered a bank account paying interest once a year. But then I noticed that I can find another account that will pay the same amount of interest, 3% interest, but they're going to pay me interest semi-annually. So look how our equation changes. Instead of a 1 underneath the 3%, I have a 2. And then I have 2 times t, which is 5, in the exponent. Nothing else changes. I still am investing $130,000. I still am making 3% interest. And I still am investing for 5 years. The only thing that changes is this 2, my semi-annually compounding period. So I want to show you again the keystrokes that I use in order to sort this out. I take 0.03, which is 3% interest, and I divide that by 2. And then I add to that 1. That's inside my parentheses, so order of operations says I have to do that first. And then I raise this to the 2 times 5 power. And I would then multiply that amount times $130,000, which is my original investment. Notice that I made more money, $150,870.31. That's quite a bit more than just compounding once per year. And notice nothing else changed, just my compounding period. So the problem asks me to do this for quarterly compounding and for monthly compounding. And what I'd like you to do is I'd like you to pause the video and I'd like you to see if you get the same amounts and the same formulas that I do. So I'm assuming you paused the video and you went through the calculations. You'll notice for quarterly we have a 4 under the 0.03 and also in the exponent. And we made even more money compounding quarterly than we did compounding semi-annually. Then I compounded monthly, so I needed a 12 in the denominator here. And my compounding periods changed to 12 times 5. And I made $151,000 and $10.18. So if you compare the amount that I made compounding annually to the amount that I made compounding monthly, I made quite a bit more money with the monthly compounding. And the reason, it says, why does this option provide you with more money than any of the others? And the answer is because I'm earning money I'm going to abbreviate here. Because I'm earning money on the interest that I was paid.